Welcome back. Today we're going to be talking about proportional relationships and equations. Our content objective is students will be able to determine an equation for a proportional relationship. Our language objective is students will be able to explain in words the process of determining an equation using the correct vocabulary, such as proportional relationship, equivalent ratios, and the constant of proportionality. Why am I learning this? Well, it's important for many real-life problems like figuring out the amount of time to do a job. So here, for number 1, it says, this table shows 3 measurements of a specific type of bamboo, comparing the height to the amount of time it took to grow that height. So in this row here, we have time in days. Then here in this row, we have the height of the bamboo in centimeters. So what is the input? What is the output? I'm definitely going to say time is the input because the time is what typically determines the height of the bamboo. So if time is input, then the height of the bamboo is output. So we're going to have a few questions that we're going to answer with every single table that we see. We're going to check, hey, is it a proportional relationship? If it is, what's the constant of proportionality? What's the rate? What do you know about the graph? And what is the equation? So we have a few things to determine. So first things first, let's determine if it's a proportional relationship or not. Okay, so we're going to go ahead and check the ratios. And in order to do that, we typically do output over input. So here we're going to do the output of 120 over the input of 2. So this here is 60. I'm going to go ahead and check this set of data. The output is 180 and the input was 3. This is also 60. So far so good since the ratios are equivalent. I'm going to keep going. The output is 360 and the input is 6, which is 60. So guess what? I would definitely say this is a proportional relationship. But why would I call this a proportional relationship? Because all of the ratios are equivalent, and for that reason, it is a proportional relationship. So there's a few things that I kind of want to recap with you. K is typically the variable we use to represent the constant of proportionality, and you may have noticed that in your homework. We can find K several ways. One, by finding the equivalent ratios, which we just did earlier in the previous example. Or we can locate the ordered pair, which is 1, k on a graph. So you're looking to find when x is 1. When x is 1, whatever the y value is going to be your constant of proportionality. And then when we're writing the equation of a proportional relationship, all you're doing is writing in the form y equals kx, where k, of course, represents the constant of proportionality. So for example, in the previous example, the constant of proportionality was 60. So all you'd have to do is replace k with 60. So it would have been y equals 60x. Okay, so let's move back to our first example. Because we've determined that it is a proportional relationship, since all of the ratios are equivalent, okay, I'm just proving it to you real quick that it is proportional. This is my constant multiplier, and it works out for each one. I need to answer some questions. The first question is, what is the constant of proportionality? Well, the constant of proportionality are the ratios that were all equivalent, which in this case was 60. And remember, the variable that we use for the constant of proportionality is k. So k equals 60. Now there's another question. The next question is, what's the unit rate? So it's still going to be 60, but it's going to have units. What will the units be? Well, if you ever question that, what I would do is use one of the ratios, but include the units. This was 120 centimeters, and this was representing 2 days. So my units should be in centimeters per day. So since it's 60, I'm going to go ahead and say it was 60 centimeters per day. So notice it's always going to be in this case y over x. Centimeters per day. Then the next question is, what do you know about the graph? Well, the one thing I would know about this graph, since it's a proportional relationship, is that it should be linear and that it should go through the origin. Okay, what else? Well, the last question that it's asked is, what is the equation? So before we write the equation, it's important to remember what we saw in the previous slide. We are going to be using the form y equals kx. Now, before I go into that, there's going to be moments where they might specify the variable they want to use. So we might not always use y and x. So here, they're going to ask us to use t for days and h for height. So if you want to, remind yourself that the x is the input, y is the output. So instead of using y, I'm expected to use h. And here, k is 60, so I'm going to go ahead and replace it with 60. And instead of using x, I'm supposed to be using t. Now, real quick, I want you to understand what this equation means. It means the height of the bamboo is determined by multiplying 60 by the number of days, which makes sense since it is growing 60 centimeters every single day. So my equation is h equals 60t. So keep in mind that the general format is y equals kx. However, depending on the scenario, you might be asked to use different variables. Okay, so the constant of proportionality was 60. The equation was y equals 60x, or using the variables that they gave us, h equals 60t. Okay, here the constant of proportionality is 7. So what would the equation be? Well, it's going to follow the format y equals kx. So it's going to be y equals 7x. So we're just going to replace k with a 7, but keep the x. Okay, let's practice some more. If the constant of proportionality is 4/5, what would the equation be? Well, it's going to follow the format y equals kx. We're going to go ahead and keep everything except we're going to replace k with 4/5. And we're going to go ahead and keep the x. So my equation is y equals 4/5 x. Now notice, I'm only able to do this if the equation is a proportional relationship, which makes sense since they are giving me the constant of proportionality. Okay, so remember, for the next few problems, we are going to be expected to answer these questions. 1, is it a proportional relationship? If it is, what's the constant of proportionality? And if it is, what is the unit rate? If it is, what do you expect to know about the graph? And last but not least, if it is, what is the equation? Number 2, it says the table gives the price for a different number of books. So for our first row, we have the number of books, and the second row, we have the cost in dollars. The first thing we're going to want to do is identify what is the input, what is the output. I'm definitely going to say the input is the number of books. Why? Because the number of books is independent. It's what's going to determine the cost. So for those reasons, we're going to call the number of books the x, and the cost is y. Once again, because x is your input, it is independent, and y is your output, which is dependent on the input. So let's go ahead and start with the graph. Let's label our x-axis, which should be the number of books. We're going to go ahead and scale that. We're going by increments of 1. And then we're going to label the y-axis, which is the cost in dollars. And again, here, since we have to go up to 32, we're going to go ahead and go by 2s. Now, once again, remember that just because we see the first value is a 10 doesn't mean it's going by 10s. It's actually going by 2s. So you'll see here it's going by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So just keep that in mind. So with this first ordered pair, x is 3, y is 12. So I would have the ordered pair 3, 12. So I'm going to go 3 over 12, which is right here. The next ordered pair would be x, y, which would be 5, 20. So I'm going to go over 5 and up all the way to 20. And the last but not least is the ordered pair x, y, which would be 8, 32. So we're going to go all the way to 8 and all the way up to 32. Now, you would use a straight edge and you would draw a line. Based off of this graph, I have a lot of information which will allow me to determine whether or not this is a proportional relationship. I'm going to say it is. Why? Number one, it is linear. It is a straight line. Number two, it goes straight through the origin, which is a requirement for it to be a proportional relationship. But real quick, let me check the ratio, just to kind of double check my work. The graph definitely proves it, but so should the ratios. Why would I check my ratios if I already see it in my graph? Because sometimes when you're graphing, especially if you're graphing freehand with a ruler and a pencil, there might be slight variations in where you plot the points and where you place your ruler. So checking the ratios is a great way to guarantee that it is a proportional relationship or not. So ratios are always going to be output over input. So for the very first one, we're going to have 12 over 3, which is 4. Then we're going to check the second one, which is output of 20, input of 5. So 20 over 5 is also 4. So far so good. The ratios are equivalent. And last but not least, the output is 32 and the input is 8, which also gives us 4. So this is a further proof. Since the ratios are equivalent, I know for sure that the information here is a proportional relationship. So since I've checked all the ratios, I can see that since they're all 4, that is my constant of proportionality. Now that we found the constant of proportionality, the next thing is to find the unit rate. Okay, what does this 4 actually mean? Well, the 12 was referring to the dollars, and the 3 was referring to the books. So that means it costs $4 per book. So that would be my unit rate. The next question was, what do you know about the graph, which we technically already answered. We know it is a straight line and it goes to the origin, and we clearly see that. And the very last question is, what's the equation? Well, the equation should be in the form of y equals kx. I am going to replace the k with a 4, so that means my equation is y equals 4x. What does this mean? Well, y means the cost. So the cost is going to equal 4 times x, which is the books. So the cost is going to be 4 times however many books you buy. Now, what would the value of y be in 1 comma y for this scenario? Why am I wanting to know this? Because once again, if you look at a graph, you can also use the graph to determine the constant of proportionality. So here, if I were to look at 1 comma y, here is 1, here is y. What is this value right here? Well, this ordered pair would be 1 comma, and since these are going by 2s, it would be 2, 4. Here, once again, you can see this is yet another way for you to find the constant of proportionality. So there are several ways. You can, of course, read a graph, specifically look for 1 comma k. You can see it in an equation. You can see it by checking the ratios like we've done here. So note that there are several ways to find the constant of proportionality. Number 3. The table shows 3 measurements of special color of paint and comparing the number of cups of blue paint to red paint. So imagine this paint, if it were mixing blue and red together, it's probably this purple color. It has specific measurements, certain ratios. When you use 3 cups of red, you're going to use 2 cups of blue. If you're using 12 cups of red, you're going to have to use 8 cups of blue. If you use 15 cups of red, you're going to use 10 cups of blue. So here, does it really matter which one's input, which one's output? No. But we typically keep the first column or first row X, or this second column or second row, depending on the scenario, Y. So for that reason, let's go ahead and label this X value the red cups, and then this Y axis the blue cups. Notice we just went by ones because the values aren't too big. Okay, so this first order pair is going to be 3 comma 2, so we're going to go over 3 up 2. The next one's going to be 12 comma 8, and again, it's just because ordered pairs are written as X comma Y. So we're going to go over 12 up all the way to 8, which is right there. And last but not least is 15 comma 10. So we're going to go all the way to 15 and up all the way to 10, which is right there. So using a straight edge, aka a ruler, you're going to go ahead and connect these points, and you're going to notice something. Hey, this is linear and it goes to the origin, so I know for a fact it's a proportional relationship. Now, I want to know the constant of proportionality. One popular way would be to check the ratios. So let's do that. Ratios should be written as output over input. So we're going to do output, by the way, just a friendly reminder, that's going to be your y, and input is going to be your x. So here it's going to be 2 over 3, which is just 2 over 3. Then we're going to do 8 over 12, which reduces by 4, which also leaves us with 2 over 3. And last but not least, 10 over 15, which can be divided by 5, which also leads us to 2/3. So the ratios further prove this is a proportional relationship. But why did I do that? Well, this ratio is going to allow me to find the constant of proportionality. The constant of proportionality is 2/3. Now the next thing on my list was to figure out the unit rate. So I already know it's 2/3, but what are the units going to be? Well, your units will always be set up as y over x. So in this case, if it's y over x, that means it's going to be blue cups per red cup. So what is the unit rate? The unit rate is 2/3, that's from the constant of proportionality, of cups of blue paint for every 1 cup of red paint, blue per red. So the equation would be y equals 2/3 x. And again, how did I get that? It's just y equals kx. We replaced k with 2/3, and that's how we ended up with our equation. Now, what would be the value of y in 1 comma y for this scenario? Now here, if you look at the graph, you can't really see it. However, we do know that y should always be k, right? And we already know what k is. So the y value would be 2/3. I know this because that's what the unit rate is. Okay, number 4. It says, this table shows 4 measurements of the amount of dirt excavated compared with the amount of time it took in hours. So H is what they want you to use for hours, and Y is what they want you to use for yards. So here is my setup for the graph. Notice this is my input, which is Y. It is placed in the spot of the x-axis, and this is my output, so that's why it is placed in the y-axis. Notice the hours is what's going to determine how many yards of dirt is excavated. That's why this is the input and this is the output. So let's start graphing. We're going to graph 1 comma 4. We're going to graph 2 comma 8. We're going to have 3 comma 12. And we're going to graph 5 comma 20. So looking at this graph, I notice it's linear. I notice it goes to the origin. So already I know it's a proportional relationship. But let's find that constant of proportionality. How do I do that? By looking at the table. How? If you remember, you can find the constant of proportionality by looking for 1 comma k. I found it. It's right here. What was k? K was 4. So that is my constant of proportionality. So I can say that the dirt is excavated at 4 yards per hour. How did I come up with that? Well, the units are always written as y over x, or output over input. The outputs are in yards, the inputs are in hours. So here it would be 4 yards per hour. And my equation would be y equals 4h. Once again, y, because it's in the form of y equals kx. Here is the original x and here is the original y. So if I replace them, y is going to remain a y. K is going to be replaced with 4 since that's a constant of proportionality, and x is going to be replaced with h. What this means is the number of yards, y, is equal to 4 times the number of hours, which is h. Number 5, here we have a table of x and y's. There's no units at all. So I'm just going to have a table. I'm going to go ahead and graph these ordered pairs. The first one's going to be in the form of x comma y, so 5 comma 1, 15 comma 3, and then 20 comma 4. So using a straight edge, we're going to connect these points. Voila! I know for a fact it is a proportional relationship. Why? Because in the graph, I see that it's linear and it goes to the origin. So guess what? That means it has a constant of proportionality. It has a unit rate. So let's do that. For the ratios, real quick, I do want to mention, before we were looking, if it was possible, we're going to look for 1 comma k. Right? Because this would allow me to quickly figure out the constant of proportionality. Please do not confuse it for something like this. Okay? 1 has to be in the x coordinate, not the y coordinate. So I would not say 5 is the constant of proportionality. So just keep that in mind. So for that reason, I'm going to have to check my ratios. We always check them as output over input, which is basically y over x. So here we're going to have 1 over 5, 3 over 15, which reduces to 1/5, and then 4 over 20, which also reduces to 1/5. I expected that to happen. Why? Because my graph was linear and it went through the origin. So all of these ratios I expected to be equivalent. But now that I've checked the ratios, I know what the constant of proportionality is. Constant of proportionality is 1/5. So what does this mean? Well, it just means there's 1/5 y per x. And here I went ahead and clicked through too quickly. This is my equation. How did I get it? Well, it's in the form y equals kx. Simply replace k with our value of 1/5, which leaves us with y equals 1/5 x. So what does this mean? In order to figure out the y value, I would have to take 1/5 of the x value. So what would the value of y be in 1 comma y for this scenario? Remember, it's written as 1 comma k. I know what k is, so it should be written as 1 comma 1/5. Guess what? You survived. That actually concludes the lesson for today. Thank you so much for tuning in, and as always, until next time, bye!